Hello viewers. Every transport engineer should have the control over his transport network. If he has the control over the transport network, then he can able to maintain the SLA and also meet the KPI targets. If you want to maintain the control over the network, then you have to concentrate on two different things. One is fault management and the another one is performance management. If you talk about fault management, there are five different things are there. One is fault detection, fault verification, fault isolation, fault recovery, and finally fault notifications. In the ancient times when GSM and CDMA was there, the entire transport network was in TDM. So in that time, operator has a greater control over the transport networks. Since every site is having a dedicated path from the site to the core network, so it is very easy to control the transport network. But things have changed when we moved from TDM to packet network because of its dynamic nature and very efficient than the TDM resources. Okay, once we moved to the packet network, what happened? Lot of sites started sharing the bandwidth. Because of that, operators starting to lose the control over the transport network. Now, come on, let's see how we can gain the transport network control back with using the active performance monitoring in the transport network. Okay, why performance monitoring? We have already discussed about fault management. In this PPT, we are going to discuss about performance management. So, okay, when we are talk about performance monitoring, what are all the parameters are there? The first and the foremost thing is the delay. Delay plays a crucial role. What is delay? Delay is packet send time, packet receive time minus packet send time. That is called as a delay. Delay plays a crucial role in the handover process. If the delay is more than 30 milliseconds in WCDMA or LTE networks, then handover will not happen. The call get dropped. And the second one is the delay variations. It is improper synchronization. If the node is not properly synchronized, then delay variation will happen. What is the difference between delay and the delay variations? We have seen that delay is nothing but a constant delay between the packets. If, for example, I'm going to send 10 packets, the delay between all the 10 packets is delta 1 only. But in delay variation, I'm going to send 10 packets to the receiver. All the 10 packets receive in delta 1, delta 2, delta 3, and so on. So the delay is keep on changing for each and every packets. So that is called as a delay variation. Delay can be easily handled in the network, but delay variations can't, which is also called as jitter, can't be able to handle in the network. It requires a lot of man hours to troubleshoot or fix the issue in the network. Okay, then the third one is packet loss. Packet loss has a huge impact on the throughput. And the fourth one is throughput, and the fifth one is bandwidth. We have know the difference between the throughput and the bandwidth. Throughput is nothing but we are talking about speed in throughput, which is a actual values or a physical values, and bandwidth is a theoretical value between A and B, and mostly it is about talking about the capacity part, and it is indirectly proportional to the speed of the networking. Okay, and the last one is availability of the transport networks. Okay, so in performance monitoring, we are going to maintain all these parameters. If you have a control over all these parameters, or if you fix the problems happening because of these parameters, then you can able to gain back the control of the transport networks. Okay, what are all the methods of performance monitoring? There are two different methods out there to do the performance monitoring. One is active performance monitoring and the passive performance monitoring. So far, we predominantly use the passive performance monitoring, and the active performance monitoring was introduced in the data world. It's a data world in the sense it is introduced in the networking part like switches and routers, and it is adapted to the telecom standard also. Okay, let's start with the passive performance monitoring. Okay, passive performance monitoring, how we are monitoring it. There are lot of counters are there for each and every node in the transport network, as well as the RAN network and the core network. There are abundant performance counters are there. These counters every 15 minutes takes the values of these of the performance values or the performance parameters and send it to the management system. It might be a third party vendor also, the third party tool also. Okay, so if you notice the one thing, the performance counter used to take the values for every 15 minutes, and the 15 minutes is the average of all the values taken in those 15 minutes durations. Okay, and the approach is, yes, it is a reactive approach. All the damage has happened, and after that we started investigating using those counters values. So how it is useful and in which scenario it is useful? It is very much useful in finding out the root cause analysis. And if you find out the root cause analysis, then you can able to prevent such kind of accidents or incidents in the futures. And then it is also useful to find out the network congestion in your network. And it's also useful in the long-term analysis. If you have a database for last 2 to 3 years, and we can easily predict how the network behaves in the weekends and weekdays, how it performs in summer, how it performs in winter. We can able to correlate with the previous year's database. So these counters helps to do the long-term analysis. And what is the disadvantage? As we already told, the calamity has already happened. It happened, and then we started investigating on it. And the second one is counters are limited to the node. There are no counter which can able to capture the performance from the core network to the site. And so all the counters are dependent on the particular equipment. If it is a transport equipment, transport parameters or counters are there. If it is a RAN network, in RAN related performance counters are there. If it is a core network, core related performance counters are there. So there is no end-to-end performance counters are there. So that's one disadvantage of the passive performance monitoring. Okay, how active performance monitoring is entirely changed from the passive performance monitoring. So active performance monitoring, it's a totally new topic for the telecom domain. So we recently started introducing the active performance monitoring in the telecom network. And in addition to the active performance monitoring, we also introduced artificial intelligence. Because of this artificial intelligence, we can able to foresee what is going to happen in the network if the site is going to down. By analyzing the alarms and analyzing the events, we can easily predict what is the damage is going to happen for this network, or the site is going to down or not, based on these events and the alarms. Okay, how we are going to do the active performance monitoring? We are going to emulate the end user traffic, and we used to inject these simulated traffic into the transport network, and in the opposite end it was reflected back and it came back to the origin or the IP probes origin. Then we started analyzing those packets. We will see that in the later cases. Okay, and the approach, yes, of course it is a proactive approach. Before anything happens to the network, we proactively monitor the network for delay variations and packet loss. All those things has been and find out. And interestingly, we can able to check the QoS parameters also. If you change the DSCP values, then you can able to travel in the queues, in the different queues of the transport network. There are 4 queues are there. In some networks, there are 8 queues are there. If you change the DSCP values of the emulated end user traffic, then it can travel in the different queues. Then we can able to gauge the performance of the transport network. Okay, how it is useful? It is useful to isolate the fault, and second one is it is very much useful in planning the capacity of the network. Okay, what is the disadvantage? It requires a new hardware. Though it is a protocol, it requires a hardware, and obviously it adds cost to the network. Okay, methods of active performance monitoring. There are two different methods out there to monitor the performance of the network. One is Y71731 and another is one is called the TWAMP solutions. We are going to discuss about these two things in the PPT. Okay, let's start with Y71731 and Ethernet OAM. Y71731 is part of Ethernet OAM. Ethernet OAM is nothing but IEEE 802.1 AG, and Y1731 is a ITU-T standard. Okay, what it's going to do in the performance management and in the fault management. In performance management, it is going to measure the frame delay variation, frame loss, and frame throughput. If you look at the things, everything is coming up with frame, and all. So frame comes in layer 2. Yes, of course, this Y1731 is specifically made for Ethernet, and it is only it can able to monitor the performance network for the L2 networks only. So if there is a L3 network in between L2 networks, then it is it is impossible to measure the performance of the L3 network. Okay. In the fault management, what it is doing: fault detection, fault verification, fault isolation, and fault discovery. Okay. And it's also do the performance management, perform and this protocol, it's supported by almost all the backhaul devices. So you don't need a specific hardware for implementing this Y1731 protocol along with Ethernet OAM. Okay. And finally, as you said earlier, it is a L2 based solution. So if you want to introduce it to L3, so we have to go for the next method. Okay. That's why we have jumped to the TWAMP solutions. Okay. Before jumping into TWAMP solutions, let's see how Y1731 is working on it. So it is part of Ethernet IEEE 802.1 AG. Okay, here each and every segment of the network. For example, here there are four different routers are there and five different parts are there. One, two, three, four, five parts are there. So the network, this is a NNI interface and this is a UNI interface. This interface was monitored using UNIME, and operator A monitors this segment, and operator B monitors this segment, and the service provider is nothing but the fiber provider or a bandwidth provider monitors this segment of the area, and the end to end was monitored by monitor using subscriber MEs. MEs are nothing but maintenance entities, and the test MEG is also end to end between these two nodes. MEG is nothing but a maintenance entity group, and MEP is nothing but maintenance entity group endpoint. So all these performance monitoring are based on the segmentation of the network. So network is segmented into several parts like UNI, NNI, operator A, operator B, service provider part, and then we started monitoring the performance monitoring. And the performance monitoring is not doing in the segment. We can do it in the segment wise also, and we can able to use it in the end to end also. So these are all called maintenance points. Okay, how about traffic? How much traffic this protocol carries in the transport network along with the data network? Okay, the performance management frames in intervals of 10 milliseconds. Okay, with the maximum recommended transmission period being 100 milliseconds. So the performance management frames are sent for every 10 minutes, 10 milliseconds, and in sometimes in the worst case it was sent in 100 milliseconds. So if you are sending it for 10 milliseconds, then 100 frames are sent per second. If you are sending it for every 100 milliseconds, then 10 frames are sent for the seconds. It's depend upon the quality of the network, existing quality of the network. Okay, let's move on to the TWAMP. How TWAMP is different from the Y1731. So in the performance management part, it is going to measure the network delay variation, frame loss, availability, and QoS fault detection. This is a difference between these two things. And also it do the fault management, the same thing: fault detection, verification, isolation, and discovery. And then it checks the QoS settings also. We have already discussed that by changing the DSIP values, we can inject multiple TWAMP sessions. create multiple TWAMP sessions between sender and receiver, uh, and we can gauge the performance of the individual queues. Okay, separate hardware is required for the initiators. Okay, these are all called as IP probes. We need a separate equipment in the BSC side or MSC side or in the gateway side, and to measure the performance of the networking. And then it works with L2, L3, and MPLS or networks also. So TWAMP is widely adapted for the telecom grade networks now. Okay, let's see detail about the TWAMP. Actually, TWAMP contains four different logical elements. One is control client, session sender, session reflector, and server. Okay, and also TWAMP has two different protocols. They work together to monitor the performance of the network. Okay, those two protocols are nothing but TWAMP control and the TWAMP test. TWAMP control protocol, what it will do, it will create, initiate, or set up the connection and tear down the connections. And also it maintains the connections. So it initiates, setups, maintains, and tear down the connections. That is the job of the TWAMP controller. Control client here in the sense it is the host. It is called as IP probes, the one which is used to send the packets to the opposite directions. Okay, and first control clients talk to the server and they handshake with each other, and then once the connection is set up using TCP, then it advises the session sender to start the packets, testing packets or IP probes to the session reflector. Okay, session reflector reflects the packets, and then it was collected by the session sender, and then we started examining those packets to measure the delay variation, and the packet loss in the end-to-end system of the network. Okay, in the physical diagram, the session sender and the control client combines into one unit, and also session reflector and server were combined into one unit. So physically there are two units, but logically there are four different units, and the two protocols running between these two machines. Okay, let's see how it works in the transport networks now. So this is our site, and here we are going to measure the ABIS or ABIS IUB or uh, X1 connections or S1 traffic. Okay, this is a TWAMP initiator or IP probes. This TWAMP initiator periodically sends the IP packets towards the BTS. In the BTS, we don't require a separate hardware. The BTS itself will reflect that data packets, and it is coming back to the TWAMP initiator. So while examining the received packets, it started and to measure the delay variation and the packet loss. Okay, what is the role of the TWAMP controller? If there are multiple TWAMP initiators out there, it is acting as a NMS for the TWAMP initiators. So all the data will be dumped into the TWAMP controller, and then TWAMP using SNMP traps, and then TWAMP can able to create an XML interface, and it's dump the data to the higher order OSs, and from there NOC people use to access the data. Okay, similar to the active performance, similar to 1731 protocol, how much bandwidth is required for the TWAMP solutions? So 10 packets sent for every second in each session. The packets are normally not bigger than 50 bytes, resulting in a bandwidth of 8 kbps per second per test streams. So this 8 kbps per second test stream will be injected into the transport network along with the data network. So this is how we used to measure the performance of the transport networks. So the concept is same for both the network Y1731 and TWAMP. We one node, the node IP probes used to send the IP packets periodically, and the opposite side it used to reflect the packets, and the reflected packets comes back to the origin or to the IP probes, and then we calculate the time And based on the time calculation, we used to find it out the performance parameters, that is delay variation, packet loss, and the throughput of the network and all. Okay. That's all users. Have a nice day. Thank you very much.